Hello data friends. Let's explore the potential of the Medallion architecture design in Microsoft Fabric. Organize and transform your data across bronze, silver and gold layers of a Lakehouse for optimized analytics. In this exercise, we will build out a Medallion architecture in Microsoft Fabric Lakehouse using notebooks. We will create a workspace, create a Lakehouse, upload data to the bronze layer, transform the data and load it to the silver delta table, transform the data further and load it to the gold delta tables, and then explore the semantic model, previously known as a dataset, and create relationships. So usually the first step is to create new Fabric workspace, but I have my workspace already created, which is MS Learn Fabric, as you can see it here. So I'm not going to create a new one, but if you need to create new one, please do it first. So okay, I'm going to use this workspace, MS Learn Fabric, I have created, and I'm going to create new Lakehouse. So we are going to create new Lakehouse at the beginning. Let's do it. We can create it from here, or we can click data, Synapse Data Engineering, and click it here, Lakehouse. So I will call it Lab 0 or maybe sales, and click create. New Lakehouse is being created right now. And then I will upload few CSV files. So those three CSV files can be downloaded from Microsoft Learning GitHub repository. I have it downloaded already, so I can upload those files in here. So let me create first the subfolder here. So we can create subfolder and name it maybe like bronze, yeah, because this will be our bronze data layer. Bronze, which will keep all the raw kind of files, yeah, raw version of files, raw version of data ingested from the source system. So let's pretend that we ingested the files by data pipelines, for example. So I will do it manually for the purpose of this lesson, for the purpose of this lab. So upload files and choose my files. Those are those three, and open. Okay, so now I'm uploading those three files. And that's it. Previously, I've done this for the previous lab, but this is the lab we are doing right now, Lakehouse sales, and those three files should be uploaded, which we can see this in here. Okay, great. So we have our data in our bronze layer right now, yes? So let's create a new notebook and do some kind of transformation to the silver layer. Silver layer is another second data layer in our Medallion architecture. Yeah. So okay, let's open a new notebook. We will name it, clicking here, we will rename it to transform data for silver. Okay, cool. And now we are going to do what we are going to do. So first we will import some types or functions, types, and the other things from the PySpark SQL types namespace. And here I'm creating the structure of the table that I would like to create. In this case, structure of the table that I would like to read from the CSV file. So this is the structure I'm defining up front, and then reading the CSV format files with the header, assuming that those files have a header, and then applying this schema. Yeah, so I'm reading all the CSV file from all the CSV file from bronze layer, and I will display top 10 records. So let's run this code. And now we can see the data below that we have in those 3 CSV files. We see some order dates from 2021. So yeah, it's like this shows us only top 10 from the 2021, but this is like by accident. Yeah, those data are not ordered in any way, or maybe ordered by sales order number, but we can double check if we have for sure data from 2019. So we can run this code with this approach. Yeah, so we see that we have right now the data only from one file. Yeah, but in our case we want to read all 3 files, so or all the data, all the ingested data in our bronze data layer. Yeah. We are showing only top 10, but it's not a problem. Later we will do some more things. Okay, so before we save the data to the another layer, let's do some data validation and cleansing of those data. So let me prepare another cell, and with this cell we'll again import some functions from PySpark SQL functions namespace. And here we add few columns. Yeah, the first column will be is flagged. Sorry, the first column will be file name actually, where we put the original file name of the CSV file name as a column that we would like to keep this for any kind of data lineage or troubleshooting purposes if we have any problem with the data on the later stages, on the later data layers. So we'll keep this input file. We are using input file name function to get the original file name. Then we're adding is flagged. So is flagged will help us to decide if the record looks correct or is validated appropriately. Yeah? If it's wrong, we'll set true value for any, in this case, for any records that is earlier or less than order date 2019, 1st of August. So otherwise we'll set false, which means data looks correct. Yeah. So this is only one transformation we are using here, but this is only for kind of demonstration purposes. Then we are adding created TS and modified TS. TS means timestamp, which is date and time. We are creating the same value for both columns, but later on in modified TS, we can use the modified TS column for updating this column with the current timestamp when we are updating existing records in this table. Yeah. But for now, the initial value will be exactly the same because this is the moment when we first time creating the records. So create TS, modified TS are exactly the same. Okay, and then we are calculating customer name, or not calculating, sorry, cleansing customer name, setting up the unknown if the customer name is currently null or empty. So this is what we are doing with this. Let's run this code, and then the next step would be to prepare the data to be saved as a table, delta table, to the silver layer. Okay, this code was empty. This code was simple. So let's run another code. This time we are creating a delta table. If that doesn't exist in the target location, my target location is sales Lakehouse and sales silver table name, with some columns that I'm defining right now. I'm defining new columns and appropriate data types, and execute this code, which means we will create new table if that doesn't exist. Okay, so let's run this code. Fine, and then the next thing would be to do the upsert operation. So we have nothing in this table right now, but let me show you that the table already exists. Yeah, so normally I should refresh this because by default I will not see the new items. So if you click the refresh here, you will see the table that we just created and all the columns that we defined for this table. Okay, but the table for now is empty. So let's do the upsert operation. What is the upsert operation? Let me copy paste this code and explain this to you. So the upsert word is combination of two words, update and insert. So it means that we will be updating the records if the record already exists in the target table, or inserting new record if that kind of record doesn't exist yet in the target table. So for these purposes, we are using merge operation. Merge, you might be familiar with merge from standard SQL language. In PySpark we have the same. So we are doing merge, and we are matching the values or columns like sales order number, order date, and customer name. Yeah. So this is how we are matching the values. Oh, sorry, another one is silver item column. Yeah, 4 columns that we are matching. If they match, if all those 4 values match, we are updating, but actually in this case we are not updating anything. Yeah, that's why this section is empty. But actually we are interested to insert new records if the record doesn't exist yet in the target table. Yeah, so actually if you look at this code, you can think, okay, I can actually run this multiple times and it will not generate me any duplicated records. Yeah, so let's run this code right now and see what we have in the target table. Yeah, so I can click this load data, and let's see, let's maybe call it like df1 and run this. So we have some data in this sales silver table. This is our silver data layer. And actually let me change this code using SQL language this time, and just check how many records we have in this target table. Yeah, so let's run this code again, the modified version, and we have over 32,000 of records. So what I wanted to show you here, that this upsert method or merge method or merge approach actually is safe, because if we run the same code again with the same data frame, with the same data frame comes from bronze layer, we can run this code again and it will it shouldn't update any records, and also it shouldn't insert any records because those records already exist. Yeah, so I executed this again and we can check if we have any new records, and it shouldn't be any new. Yeah, we still have over 32,000 of records, which is great. That was the actual goal of this upsert operation. Great, so we have already created our silver version of sales data. Now that we have data in your silver layer, we can use the SQL endpoint to explore the data and perform some basic analysis. This is a nice option for you if you are familiar with SQL and want to do some basic exploration of your data. In this exercise, we are using the SQL endpoint view in Fabric, but note that you can also use other tools like SQL Server Management Studio, SSMS, or Azure Data Explorer. So now we are going to use the SQL endpoint. So let me go here. We have our sales Lakehouse. If we click on this Lakehouse, we can use, sorry, actually go back. Here we have our SQL Analytics endpoint. We can open that. And if we open, we are in the context of the SQL Analytics endpoint, which you can check here on the top right corner. Yeah, SQL Analytics endpoint. And we can preview some data. Let's create new SQL query. Our new SQL query will be, let me copy that here. And now I'm reading from sales silver table, and doing some aggregations. Yeah, I'm doing some aggregation. My table is here, so I can execute this code now. So as you can see, we can very quickly aggregate some data and analyze data directly from the Silver layer using SQL Analytics endpoint. So this is the first query. Let me run another one. Let's create another query, and this time I will aggregate information about the customers and their purchases. Yeah, so let's say give me 10 top customers who purchased the most. Yeah, so this is the result. Yeah, so as you can see, it's very quickly and very easily how you can explore the data using SQL Analytics endpoint. Great, fantastic. So this is how we can check and work with the data on the Silver layer using our very well-known SQL language. We have successfully taken data from your Bronze layer, transformed it, and loaded it into a Silver Delta table. Now you will use a new notebook to transform the data further, model it into a star schema, and load it into Gold Delta tables. Also, please bear in mind that you could have done all those in the single notebook, but for the purposes of this exercise, we are using separate notebooks to demonstrate the process of transforming data from Bronze to Silver and then from Silver to Gold layers. This can help with debugging, troubleshooting, and reuse. Let's go back to our workspace, MS Learn Fabric, and go to the again data engineering. Now we'll create a new notebook again. What we'll be doing now, let's rename this notebook. What we'll be doing now, we'll be preparing data for our new data layer, the last Medallion architecture layer, which is Gold. Okay, so I'm preparing separate notebook here. So let's do the first thing, which will be reading the data from the Silver layer. Yeah, because the data for Gold layer comes from the Silver very often. Of course, there's some you can make some exceptions if you need for any specific purposes or needs, but normally the data comes from Silver. Because in Silver you have data cleansed, validated, and transform or prepare with appropriate new columns, new values, and etc. Yeah. Okay, so we are reading again this sales Silver. We are reading this table to our DF data frame. And now what we'll be doing, we will be preparing a new table. We'll be creating Delta table we'll be creating new dimension this time table in our Gold layer. First table will be dim date Gold. Okay, something happened here. Unfortunately, I forgot to select context of the Lakehouse. We have our existing Lakehouse, which is sales. So let's stop the current session and restart it. So now we are the default Lakehouse that we've got for this notebook is sales. Yeah. So that's the reason why we've got this error. Let me clean the output and run this cell again. Now it should be fine. And then what we are doing, we are creating dim date Gold table. This will be our Gold layer dimension for dates. Yeah. So again, I'm creating the table if that doesn't exist in the target location. So let me run this code as well. This cell will be run after this one when it's finished, which is running right now. And let's do some transformation. Let's prepare some data for this table, for this dimension date Gold table. So what we are doing here, again, importing some functions, and then what we are doing here. So we are using this DF, which is the Silver version of sales, and we are dropping duplicates of order date and selecting So yeah, we are dropping duplicates based on the order date columns, and then we are selecting only few columns, and there will be few columns like order date. Then we are calculating some new columns based on this order date, and calculating few others, yeah, and ordering this by order date again. Now let's execute this and display top 10 records. So with this cell, we transform the data, preparing or generating data for dimension, for our first dimension, which is dim date, and we have few columns as we wished. Yeah. So now let's save this data to the gold layer with the same approach that we already know, which is upsert using merge operation. So our target location of this table is dim date gold, and this is the update. So this is the df dim date gold, the data we prepared here, and we'll be using this alias silver for source, and then preparing matching actually data based on the order date, yeah, and inserting new columns like this. So let's execute this code right now, and our data has been inserted into the target table. Actually, as you remember, we can run this code multiple times, so only new records that doesn't exist yet on this dimension will be inserted. So there's no problem to run this multiple times. Okay, so let's prepare another dimension. This is still running. Yeah, it's finished. Let's prepare another dimension. This time it will be dimension for customers. Again, I'm creating new table with the same method that you know already. Yeah, from the delta table class, there's a create if not exist method or function, and I'm creating this table with those columns and types. Yeah, so the table has been created. Then let's do some transformation using a silver version of data. And this time what I'm doing, this will be my silver. I'm dropping duplicates, and then I'm creating new columns, first and last, which is the first name and last name of the customer. If you remember my previous video, we've done this before, very simple transformation, but again, this is for demo purposes. Okay, let's execute this code, and we will have our data, transformed data, in df dim customer silver. Okay, so now what we'll be doing again, this time we'll be creating new column. We'll create ID column for our customer, because we would like to have customer ID. This is our dimension, so in the star schema it's important to prepare that column for a dimension table. So that's why we are creating what we are doing here. First, importing some function. This will be important because we'll use it here. So what we are doing, we're calculating first the maximum customer ID that is in the target table in the current dimension, and then getting the first. So this is the whole code. This is the whole line calculating the maximum customer ID. Okay, then what we are doing here, we are joining this silver with this target, and in that way, this is the way how we can calculate the missing value for new records, for new customer records. Yeah, if there is no value for any new customer records, and how we know that, because we are joining here with a left join. Yeah, so this is left join in the PySpark. So we know that for new records that doesn't exist in the currently target table, we are filling up the new records using this monolithically increasing ID with max ID +1. Yeah, in that way we are continuously numbering the customer ID. Okay, so let's run this code. And actually, if the data are ready, we can write this to the target table. Yeah, so we are starting from the scratch because we haven't had any data previously in that target table. This is the first time when we run this batch. So that's why we have customer ID starting from 1, which is great. It's a good approach. The data looks correct. So now again we are using this technique of upserting records, of upsert operation using merge. We are not updating anything, we're just inserting new records. So let's execute this, and the target table for this operation is dim customer underscore gold. So with that name we know that this is the dim customer table in a gold layer. Okay. Yes, great, fantastic. We have this, so we can, yeah, we have this data actually recorded. So let's check maybe here in the meantime, refresh this. We should have, yeah, dim date gold, dim customer gold. Those are tables saved in our OneLake. Fantastic. Let's do this again. Let's repeat these steps for products. So again, I'm creating table. If that doesn't exist, you know this code already, you are familiarized with that. So we just created a new table. Let's refresh this and check, yeah, that empty table is created. So now let's transform some data from silver layer. So that would be our silver kind of product. And yeah, we're dropping duplicates from df and then adding some new columns. Yeah, so some simple transformation. We are doing this for demo purposes. So those new columns are item name, item info. So those columns we added here. Yeah, so let's say that this is the data we would like to insert, but before we do this we would like to also calculate the new column, the ID column, which in this case will be item ID. So again, the same kind of code, very similar to the previous case. We are doing the left join to the target table. Target table is empty right now, so this is simple, but you know, that's, even if you run this for another batch, it will work and carry on the item ID, adding new incrementally added values. Yeah, so yeah, this is item ID, which means the table is already prepared for saving it to the storage, to the empty table that we created, this one. So which we are doing here, using again merge with insert only without any updates. So let's run this code. And the code is completed. Now what we will do, we will prepare the gold layer for fact table. Yeah, so all those sales we would like to represent in the fact table in the gold layer. So let's prepare new code here. So again, we need to create this table, the target table, at the beginning to make sure the table is there. With appropriate structure, that we are not missing or adding any wrong extra columns, or we are just sure that the table looks exactly as we are expecting. Yeah, so now the table should be here. Fact says gold, fantastic. And then what we'll be doing, we'll be using data frames again and creating some new columns for this sales. Okay, so what we need to do for the fact table of sales. So first we are loading the dim customer and dim product from dimension, from the gold layer that we prepared above. And then we are adding new columns like item info. And what we are doing here, let me remove a few lines here. we are joining df1 and df2, which is the aliases for this df, for this data frame, for dim customer, and also df3 will be alias for joining to the dim product. Why we are doing this? Because we are doing left join operation to these dimensions. Why? Because we would like to do the lookup to those dimensions and replace appropriate columns which is in the sales. We would like to substitute this with the appropriate ID, with the item ID or customer ID, which is the appropriate way of populating the data in the star schema. This time this is the fact table. Yeah. So at the end, when we've done this, we are going to select only a few columns and order by, and then execute this code. Let's do this and see what we've got at the end. So at the end, we have this customer ID calculated, item ID calculated based on the values that we've got previously in the sales tables. Yeah, so we were looking for the item name and looking for the dimension to the product dimension, and replace it with the surrogate key. Yeah, so this is our item ID surrogate key from the product dimension, and this is dimension of customers with the ID as well. Okay, so in that way we have our fact table prepared. And what we would like to do as a next step, of course, you know this already, we would like to upsert the new records to the existing tables. So in this case, again, without update, we are not doing any updates. We are only inserting the new records. So let's execute this code. And in that way, new records will land in the target table, which is in this case fact sales gold, our gold version of sales. In our workspace, we can now use the gold layer to create our report and analyze the data. We can access the semantic model directly in our workspace to create relationships and measures for reporting. Note that you can't use the default semantic model that is automatically created when you create a Lakehouse. So then we must create a new semantic model that includes the gold tables we created in this exercise from the Lakehouse Explorer. Now in our workspace, let's go to the sales Lakehouse. And we see this semantic model here, but we want to create new one. So let's click on the sales Lakehouse, and we can create new semantic model. Okay, let's name it sales underscore gold. That's the name for our new semantic model. And we would like to add all those 4 tables that we already just created in our notebook in the gold layer. Yeah, let's confirm that and create the semantic model. Now, new semantic model is being created, and all those 4 tables will be added. And the last thing I would like to do, I would like to create the relationships between those tables. So let's wait a few seconds. Now we see this. Let me hide these panels. Now let's close this, and we would like to do some relationships. Okay, so what kind of relationships we would like to do? Of course, between dimensions and our fact table. Yeah. So the first relation is between customer ID and customer ID from dim customer. So let's do that. Yeah. So now we have fact and dim customer. Relation is many to 1, which is 1 is here in dimension, which is correct direction. So I can click save. We should be able to when it 1 to many in here, so we can double check if this is correct. 1 to many, yeah, which is correct. And then let's do the same for item ID from fact sales to item is here. This is our dimension product. Item ID is here. Again, click save. So again, many is on the side of fact table, which is correct. And the last thing is order date. In this case, I'm doing the relationship between order date here and order date here. Again, the same situation, and click save. So the relationship is visible here. From here, you or other members of your data team can create reports and dashboards based on the data in your Lakehouse. These reports will be connected directly to the gold layer of your Lakehouse, so they will always reflect the latest data. Thank you very much for watching this video. If you want to learn more about Microsoft Fabric, visit Microsoft Fabric community website, which is phenomenal knowledge hub for this product. In the meantime, have a fantastic day and see you in the next video. Bye bye!